So on this one, we're having to solve this equation. Since it has the same denominator, that means that we can just add across the top. Okay, so since it has the same denominator, we can just add across the top. So x plus 3x is going to give me 4x. 1 plus -4 is going to give me -3. And we're going to keep x in the bottom. Now that we have it set up like that, we're going to do the butterfly method. So x times 5 is going to give me 5x. 4x minus 3 times 1 is just going to give me 4x minus 3. I'm going to subtract 4 from both sides. And so that's going to give me x equals -3. If I plug the -3 into this equation, would I get anything undefined? No. So then it works. When we have something like this, it has f of x is greater than 1. So if we have this, then we are going to act like there's no inequality. Okay, so if I have it just set equal to 1, I would cross multiply, right? Okay, so that's just going to give me x minus 3 equals -1. And then I would add 3 to both sides until x would equal 2, right? Okay, now if I take 2 and I plug it back in, I take 2 and I plug it back in, watch what happens. -1 divided by 2 minus 3. -1 divided by 2 minus 3, which is -1. -1 divided by -1 is what? Okay, now is that greater than 1? No. It's equal to it, but it's not greater than. Okay. Looking at my graph, this line right here is going to be y equals 2. Okay, which is essentially, I'm sorry, y equals 1. No, it's y2. Y equals 2. Okay, which is essentially what's happening right here. Okay. Oh, okay. Okay, guys, I need y'all to stop talking. So this line right here is y equals 1, which means that we want to know when the function is going to be greater than 1. And so that's going to happen between 2 to 3. So the way that we write that out is we say from 2 to 3. All right, ready? All right, so we're going to take this and we're going to multiply over here. And then we're going to take this and multiply down here. So this is going to be, and this is 1 down here at the bottom. That's going to give me -1 times 4x plus 4. And that's going to be equal to -5x minus 6. We're going to distribute that -1. And so that's going to give me -4x minus 4 equals -5x minus 6. We're going to get our x's on one side, numbers on the other. So we're going to add 4x to both sides. And so that's going to give me -1x minus 6. We're going to add 6 to the other side. And so that's going to give me 2 equals -x. We'll divide by -1. So x is going to equal -2. Wow. Once we get here, remember, this is an inequality. It's not an equation. Okay, so what's going to happen is when you have a number that you solved for, okay, what you want to do is you want to pick numbers that are below it and above it. Okay, so what's a number that's above -2? Doesn't matter, right? Okay, let's plug in 1 just because that's going to make it a little easier to plug in, right? Okay, so if we plug in 1 into this inequality, we're going to have, I'm going to do this in a different color. Yeah. Okay, so we're going to have -5 times 1 minus 6 over 4 times 1 plus 4. And we're trying to check and see if it's equal to or less than -1. So when we simplify this, it's going to give me -11 divided by 8 is negative 11/8 less than or equal to negative 1? It's less than, right? Okay, so yes. I need us to find another number that is less than negative 2.
You said the first number was greater than negative 2, right?
Negative 3 is less than negative 2. That's okay. So I'm going to plug in negative 3 into this. And that's going to give me negative 5 times negative 3 minus 6 divided by 4 times negative 3 plus 4. If we simplify this, this is going to give me 9 divided by negative 12 plus 4. That's going to give me negative 8. Okay. So is this less than, plug into Desmos. Okay, so we're going to go into Desmos. And I'll put this back up there in just a second. When we type this in, we're going to get this graph. What we want to look at is when our y values are less than negative 1. We're going to draw a line at y equals negative 1. So when is that the case? Well, we want to see when it's less than negative 1. So negative 2 and below, right? Okay, so we're going to say from negative 2, negative infinity. Okay, now there is a little bit of a gap in between here and here. So this right here is a vertical asymptote. Where is that located at? At negative 1. Okay, so it is also true from negative 1 over to positive infinity. So the way you're going to write your answer out is negative infinity to 2. And then from 1 to positive infinity. Okay, so let's talk through this one. So Juan solved the inequality, but he forgot to write the final answer. Okay, so looking at this inequality, the first thing that you want to do is you want to isolate that number. Okay, so you're going to add x to the other side. Then he subtracted 5 and got it set equal to 0. Remember, we can only combine fractions if they have the same denominator. So he multiplied by x in the top and the bottom. He then combined like terms. And then he factored. If you solved all of these factors, like if you set all of these equal to 0 and solved, what would you get? You would get x equals negative 3, 5, and then there's also 0 on the bottom. Okay. When you solve that stuff out, those are going to be the numbers that you kind of check from. Okay. So once you've factored and you have it in factored form, you can use those numbers to check in between. So in this case, he picked 1 to test. He plugged in 1 into the inequality, saw if it worked. It did work. Okay, so from 0 to 5, those numbers work. Okay, it did not work when he checked x equals 6. That was false. Okay, from negative 1, he plugged in. It did not work there. But when he plugged in negative 4, it did work. Okay, so he's going to say from 0 to 5, and then from negative infinity to negative 4. This would be our answer. Let's check. Okay, so okay, so you wouldn't cross multiply on this one. Okay, and the reason why is because it would give you 0, right? Okay, so this is already in factored form. So if you set both of these things equal to 0 and solve, you would get x equals negative 7 and positive 3, right? Okay, so now we're going to use that whole like number line system that they had. So that's going to be 3 and -7. So I need you to pick a number that's in between -7 and 3. Why do you never pick 0? Okay, we're gonna have to pick 0. Okay. Yeah, I know. I asked and then I'm negating it. Okay, so if I plug in 0 into this equation, okay, I would get -7/3. Does that work? Is that greater than 0? No, false. Okay, so it doesn't work in the middle. Now we're gonna check to the right. Pick a number that's bigger than 3. I heard 4. Okay, yep, she did. Great. Oh, all right. So we're gonna plug in 4 into this inequality. So 4 plus 7 divided by 4 minus 3. Okay, and so that's gonna give you 4 plus 7 is 11. 4 minus 3 is 1. Is 11 greater than 0? Okay, so it does work for this side. Okay, and then we want to check the other side. -8. Okay, so we're going to take -8. We're going to plug it into the inequality and check. -8 plus 7 divided by -8 minus 3. -8 plus 7 is going to be -1. -8 minus 3 is, so that's going to give me 1/11. Is that bigger than 0? Yes. Okay, so it works from -infinity to -7, and then from 3 to positive infinity. Okay. Not the let's go. Let's try plugging this in, because Desmos carries, right? Okay, so we have -x plus 8, and then we're going to divide it by, might tell me what the other thing is. X minus 2. And we're trying to see if that's greater than 5. Is that what I said? Okay, so y is equal to 5. Okay, so if y is equal to 5, and we want it when it's greater than, okay, so it's greater than 5, right? Okay, so the only time that happens is from 3, and then there's a vertical asymptote at 2. Does that make sense? Okay, so that's why knowing either how to pull a vertical asymptote from the equation is important, or looking at the graph is important. Okay, so we have a vertical asymptote at 2, and then it goes until 3 that it's greater than 5. Okay, coming back to our equation, sorry, inequality. This is how I went about solving this one. Okay, the only thing that you do need to pay attention to is that it says this equal to. Okay, so we're gonna say from 2 to 3, and it's gonna have brackets on the right side. On the left side, we're trying to see if it's equal to it, and it's not, but it still works. So we're gonna have a parentheses on this one. Okay, so if I take 3 and I plug it in here, okay, it gives me 5, right? Okay, if I take 2 and I plug it in here, it does not give me 5, but it gives me a number that's greater than 5. Does that make sense? Okay, so that's why this guy is a bracket and this guy is a parenthesis. Okay. You can do it that way too. You could do 3, and then you would have to pick 2 and then see that the numbers in between those two things would work. March 28th. Once you get here, if you cross multiply and you solve it out, you get like a number equals like a different number, right? Okay, so I would suggest on these, okay, like where you get like some weird thing, I would go in and type this into Desmos. Okay, already from that inequality, what are we gonna know about the vertical asymptote? What's the vertical asymptote gonna be? I'm hearing some S. Okay, real specific, y'all. Real specific. All right, so it's gonna be -6, right? Okay,
I said
and we
6.
want to know,
No, you didn't. You said like -5.3 or something.
okay, so we want to know when it's greater than -2, right? Okay, if you have not muted yourself, please do that. When it's greater than -2, so we're gonna have y equals -2. And so when is that the case? Well, it's whenever it's greater than -2, so that's gonna be from -6 to positive infinity.
On Tuesday, March 7th. Okay, thank you for the presentation.